Hey folks, Quilly18 here, and welcome to episode 2 of Project Caprica, our Unity tutorial where we're making a 4X space strategy game. And in the first episode, we did a sort of sketch, a visual sketch of what our interface might look like and what kind of implications that might have to the rest of our game design. But today, we are actually going to start programming. We are going to be writing the various classes that are going to be keeping track of some of the data in our game. Of course, we're going to be separating out some of the data versus presentation, as is often a really good idea, and I think it fits this kind of scenario very, very much. So I think we can go ahead and start just writing some code. I think I'll make a folder over here for something like, I guess we'll have a scripts one, and then I'm gonna make a data folder, model folder. Well, model is a little like your classic, model view controller kind of nomenclature sort of applies, but model means something else in a, 3D game engine. That might be confusing. And data honestly isn't even that accurate either, because we're not actually going to be keeping data in this folder, but I think it's going to be fine enough. So scripts data. So we're going to start with some sort of big thing called, well, normally I'd call it like the world, class, the world object, but maybe universe in this case, galaxy. I guess galaxy is fine. We could have just called it map, but that might be a little bit confusing because we might use, various, like we might refer to maps as like the visual portion of things. I think galaxy, is a pretty solid idea. Now, a galaxy is going to contain star systems. So this is a star system class. And inside of that, there's going to be, we're going to call it planet, but sometimes this will also encompass something like a, or is it? Yeah, probably. Something like a asteroid belt or something like that. Now, it's very important to note that a planet and a colony are going to be two different things. Planet is just going to be the data about the celestial object itself, and there may be a colony on that planet, or there might not be. All right, I think these are the first four I sort of want to start dealing with over here. And I don't think we're actually going to do a whole heckin' lot on the galaxy side right now. The galaxy is probably going to be responsible for some of our initial map creation. But, so, galaxy, star system, planet, and then colony over here. Now, we're probably going to want some sort of namespacing system. In fact, we can probably just create some sort of, like, Project Caprica or just the Caprica namespace or something like that. That's probably okay. What is a namespace? A namespace is, in a certain sense, doesn't do anything. In a certain sense, is just here for organization. What it does is, let's say you want to create a class called GameObject. Well, Unity would be like, hey, there's already a class called NameObject. But if you do it within a namespace, so the Caprica.GameObject is different from the Unity.GameObject. So it just makes you able to have your classes and know that no matter what you call your classes, they're not going to conflict with another class name. There's a little bit more to it, but that's really the big part of it. And in fact, in our project, we could have more than one namespace if we wanted. By the way, all these usings are importing a namespace is what it is. So something like GameObject is actually UnityEngine.GameObject, for example. So it just lets you separate out, and you can do that within your own project as well, especially if you bring in other libraries and things like that. So Galaxy is not going to be derived from MonoBehavior. It is very much going to be just a standalone class, and we don't know what it's going to have, except I'm willing to bet we'll probably have something like a list of star systems, at the very least. It wouldn't surprise me if we might have a list of all the planets in here as well. It's just an extra way to search things. I suspect we'll probably have lists of players and things like that. But to start off with, we know for sure we're going to have a list of star systems. Whether or not it's public or a property or whatever, we don't know yet. We'll just put this in here, because it's probably going to be, but I don't know how it's going to be organized, how we're going to access these things. Part of me kind of wants to keep the implementation hidden. Like, it might be a list, it might be an array, maybe we have some sort of dictionary. Probably this will in fact be protected or private one way or another. Here, we could explicitly make it sort of private. Like, no one outside of Galaxy needs to know how we're organizing the star systems. And then what we're going to have is some sort of public star system, get star system, with some sort of like ID-based system. Like, how are we going to refer to these various ones? I mean, I can certainly see something like, StarSystem ID is just going to be an integer. I guess this... See, I like ID with double caps like that, but this is sort of like your more typical one you see in programming. And I don't know. It looks a little dumb to me, but it is more convention, so I think we'll go with that. And then it will just be something like return StarSystem with this ID, maybe with a check to make sure that it actually exists, and yada, yada, yada. Oh, not StarSystem, but StarSystems. Something kind of like this I can see us going for. So let's leave it in there just as an idea for now. I like the idea of referring to things mostly by an integer rather than passing pointers around, right? If you have pointers, let's say a planet, okay? It's very conceivable for you to imagine that a planet might have a pointer to its own star system, so we can refer to things that way. The problem is when you go and you're trying to save things and whatever, those relationships, or maybe the planet's a bad example, but you have a fleet of ships. And the fleet of ships is in some sort of star system. So the fleet of ships has a pointer to a star system. When you go to save your game, okay, like, you're playing the game, and your player goes to, file, save game kind of thing. How do you save a pointer? Well, you don't, right? Your save file can't really contain a pointer, and you can't load a pointer. But instead, if the ship fleet simply had a reference to the ID of a system where the ID was just an integer, well, then you could just save that. And then on reload, you load your fleet, and it's got some numeric value in there for the system ID, and it's like, oh, okay, so you just belong to there, no problem. And so I think we're going to do a lot of that, and I think it's going to be a good idea. Now, our ID representation might change. We might wrap it in something. In fact, we're going to see that kind of aspect in just a second here. But probably something of this nature is a good idea, rather than, first of all, expose how we're organizing in terms of lists and stuff, as well as avoiding keeping references to pointers and things like that in our saves. Okay, anyway, star system. Let me go and just copy this line over here. We'll do a little something like that. Again, get rid of the mono behavior. And close this over here. So we have some sort of star system class. And again, I suspect it's probably going to have a list of planets. Now, for the star system, I actually see, rather than a list, like the thing that's good about the list, I was going to say collection, but there's a word I'm looking for, and I can't think of it. Anyway, for the list collection, the advantage to it is that it's really easy to grow and shrink because it's all handled behind the scenes. Now, there's nothing that says you couldn't grow and shrink a fixed array either. You just have to write your own code for it to add things. But the fact of the matter is, from a presentation point of view, there really is going to be a limit to how many planets you'll ever have in a star system, because our window is really only going to be able to show so many at a time. Now, how many is that going to be? It's going to depend on the size of the window, the graphics, how much space we want sort of between each planet thing. But I'm willing to bet we could probably expect some sort of thing like, we'll never have more than, say, like 6 planets will be the limit in a star system, because anything more than that, it looks stupid. So what I'm going to propose is that we have some sort of const define. And it could totally be private, like it's just internal to the star system here. And we have something like max planets. And we set it to something like 6. I mean, we could change this later on. We can do all kinds of things. What are you complaining about? Oh, because I didn't actually specify your data type. Excellent. And then for our planets, we will have, so again, we'll keep it private, because there's no reason the outside world needs to know how we organize this, and we'll force them to go through our various accessor functions, whatever they may be. And this is going to be an array of planets, like this. And yeah, planets, and that's going to be okay. And in here, we can't can we do that? No. But in our constructor, which will be, I guess, convention is keep the public constructor up here, star system. I mean, whether or not it's a default constructor or if it's got parameters, we'll see how it goes, but it's probably doing something like planets equals new planet max planets, like that. And you're going to say, well, what if the system has fewer than 6 planets? Well, I think the way it's going to work when we're drawing the star system, we're going to have each orbit is going to be a certain distance away from the sun, visually speaking. And it's going to be a fixed distance, probably, just for representation. We'll probably have round fixed distance orbits, just because we're not supposed to represent a realistic star system. We're supposed to do a representational star system, right? Where you can see the sun and you can see, all right, planet 1, 2, 3, 4. So anywhere in this array, so let's say, in this array here, planets, so the third planet is just a null or something like that. That's just a planet that's not there. So there's going to be a gap. And that's fine. And I mean, when you instantiate this, it's going to be an array of null planets, and we'll populate some of them. And that's all there's going to be. And I think that's going to be a very simple way to go about it. So, in fact, it will be very rare for a star system to have all 6 planets, I will suggest. It could probably happen. We'll have some sort of like random system for populating these planets. And once we figure out like, there's going to be different planet types. There's actually going to be different sun types as well. Let me come back to this. So we're going to have, your just rocky, just terrible planet, maybe one that's blasted by the sun. Then you have your more colonizable sort of terrestrial or oceanic planets or something like that might be in that sweet spot. There's the, what's the term in astronomy? There is a term for a planet that's sort of in the sweet spot, the habitable zone, right? Because if you're too close to the sun, it's too hot. If you're too far away from the sun, it's too cold. You can't have liquid water, right? It's actually, the whole thing, I think, is based on the zone in which you can have liquid water, where it doesn't boil away and it doesn't freeze up, because that's thought to be the most important thing for life. So there's a little band around the sun. Depending on the temperature of the sun, there's going to be, the sweet spot will be closer or further away. And there could be other things that can affect those things, but that's okay. Words. Yeah, so when we generate the star system, the planets, maybe the first 2 slots are more likely to just generate, say, barren worlds, and the last 2 slots might be more likely to have either barren worlds or gas giants, for example. And it's really just the middle 2 slots that have the best chance of a terrestrial planet, but all of them will probably have chances of having no planet whatsoever. So anyway, we'll look into that later when we talk about our actual map generation and how we might want to organize things. But okay, I think that's okay. And again, presumably, I was going to say something like, interesting. So I was going to say something here, like we're going to want, what has focus here? Why can't I type? There we go. Public planet, get planet, int, right? Planet ID. Right? I was going to say something like that to represent something very similar to what we have here with get StarSystem with the StarSystem ID. The problem is, what we're returning here is not a planet by ID. This is not the ID of the planet. This is the position of the planet in this star system. You know what I mean? This is the position of the planet in this star system. Now, to a certain extent, the full ID of a planet could be some, you can think of it as, well, it's a star system with an ID and a planet with an ID. And that's kind of okay. The other thing we could do is, say in our galaxy, we could have one central list of all the planets, and the ID of the planet could simply be in here. Those are both very valid ways of organizing. I don't know if there's a sort of pro and con to either one. Again, we might want a centralized list of all planets, although, I mean, that might help when we're doing the end of turn process, but there's no reason we can't just process through each star system and then that. Let's go with this first because, I mean, from a logical point of view, it sort of makes sense that planets are just something inside a star system. But I'm going to put a pin here and say it's possible that all of our planets will actually be in some sort of giant list in the galaxy. And instead of this being an array of actual planet references in our star system, it could be an array of ints, which are actually the planet IDs. But for now, we're going to be okay. I'm going to explicitly rename this. Instead of saying planet ID, just to make it more clear, it's going to be something like planet position. So planet position 0 through 5 in this particular case. Again, the outside world doesn't necessarily need to know what our max number of planets are. That's why I made it private over here, because hard coding things is always dangerous, because these numbers might change. But this is in such a little restricted area that it doesn't matter. The only piece of code, if we need to know what the maximum number of planets is anywhere other than the star system class, then I think in that case we're doing something wrong. Because otherwise we're just going to be like asking the star system, hey, give me a list of all your planets or whatever, because only the star system should be able to spawn its planets or do something like that. And it'll probably be some sort of system. Again, these things may change, but I think we're good here. Okay. Oh, there's something else I want to do. So we want to have different classes of stars, different classes of suns, okay? Because we could have a red dwarf, we could have red giants, we could have, well, I suppose brown dwarfs and neutron stars. I don't know, maybe, could be. Yellow stars, white hot stars, these sorts of things. Basically, it's a combination of in real life, it's a combination of the size of the star as well as the temperature of the star. And really, those things are sort of sub-derived from, like, age. Like, the sun has an initial mass and an age, and that implies all kinds of things in the solar cycle. I don't think we're going to care about, like, the true, like, astrophysics behind it. I think what we're going to have is some sort of either an int or an enum to define the type of star. Now, I mean, in a sense, it could be an enum where we actually name them, right? We have a list of like, oh, it's this star, it's this star, it's this star. I sort of think a single int that implies something mostly about the sort of temperature of the star, because in classic Mu, cooler stars are implied to be older star systems and are actually, or let me start the other way. Hotter stars are implied to be younger star systems, and the planets are mostly like nasty, lots of volcanic stuff. They're still settling down, but there's a lot of minerals at the surface. So younger stars imply richer but less hospitable planets, whereas the other side around, cooler stars imply older, more stable planets that might not have a lot of churn, and so minerals aren't as easy to get to. So it's more mineral poor, right? Fewer mineral rich planets, but more habitable because the planets are, more chilled and relaxed at that point, is the way that classic Master of Orion sort of used the star system. So if you're looking at your map and you're seeing a red star, probably there's more habitable planets there. If you're seeing a white star, then you're likely to see fewer habitable planets, but richer ones. Yellow stars were the sweet spots because it was a good balance. You tended to find richer planets and more habitable planets in general. So it would be that sweet spot of finding a habitable planet with a good number of minerals on it. And so with that, we could just have some sort of integer representing like the star age / temperature, right? Star class, right? Or star type. Maybe something like this. Where 0 equals yellow, positive equals, say, older, less rich, and negative equals younger, less habitable. Something of that nature. And then, then you pick an appropriate graphic to represent that, and you use this when you're generating your planets, right? We're going to have some sort of private void generate planets or something like that. Well, it's not private. It's probably going to be public and called by, our map generator or something like that. But this is the thing that's going to be responsible for generating the planets. Or I suppose the public thing will be generate the star systems or something. I mean, unless it's part of the... I guess it might be part of the constructor. There might be a couple of different constructors. One is it constructs it from, like loading a file, and another one is a constructor that is like, okay, generate a random set. So I guess this could be private, that it's called by our constructor, in some way. Just as a note here. Something like that. And then over here, generate 0 to max planets, weighting planet class based on star type plus distance from the sun. So some sort of thing like that. But we'll get into those specifics much later on. But by sort of planning it and thinking about this in the future, it's like, okay, well, does our structure sort of make sense? Does it sound about right? Yes, I think it's sounding vaguely right. And this is good, and we can continue. Now, we talked about, well, we want the look of the star to be based on the star type, plus probably some randomness. How are we going to figure out the look of the stars? Now, this is really meant to be really the data of things, right? This is data about the star, and we're going to separate the data from the visual layer. Still, the visual layer is going to need to know what the star should look like, and that should be consistent, right? Across saves and whatever, right? A star shouldn't look like a certain thing in one save, and then on another one, look like something else from our randomly generated star list. Because we might want, like, yeah, so it's the same, yellow star, but maybe we have 10 different graphics for these yellow star types, or 3D models, or however it is, going to be implemented. And so we want them to be consistent. So I think it sort of makes sense that we might want to keep track of what the star graphic is here in this data class. Even though the data class isn't ever going to do anything with it, it's just going to track it for us. But what should that be? What could a graphic be? Well, I mean, we could have a reference to a sprite, or maybe there's just going to be an array of graphics used by our graphic system. So really this is integer that represents the position in the array. Or maybe it's going to be a string with the file name that we use. We kind of don't know. I mean, we don't know what we're going to do later on. But more importantly, the StarSystem class doesn't need to know. It shouldn't give a hoot as to how our graphic system actually works. We're just doing a favor by keeping the bookkeeping. So what I propose here is we create a public class in the same file, it's probably fine, called StarSystem Graphic. And this is just going to be responsible for holding that. And we don't know what it's going to be. Int, string, sprite. We don't know what it's going to be. We don't care. We don't care. It could be a texture. Model. I mean, it could be a combination of multiple things. It could, do we maintain animation data? Like, we don't know. It could be any of these things. We don't care. Well, all we're going to have is and I'll make it public for now. It might turn into some sort of accessor or something like that. But it's going to be StarSystem Graphic. And I think we can just do this and do that and done. It's just an empty class right now. We don't care. All we're going to do is we're going to do the rest of our system a favor by keeping track of that. And we're going to do the same exact thing in the planet over here. So let's go, we're going to copy this namespace idea like that. We're going to close the namespace over here, get rid of the mono behavior bits there. I think, I accidentally hit insert over here. So let's get rid of you. And we'll do the same thing where we have a public class planet graphic, which is just going to be that. That's what I called it, right? StarSystem graphic. Yeah. So I mean, we're going to have stuff. We're going to have an initial or a constructor, and we'll have some sort of public planet graphic. And at some point, this will get filled out. If this turns into be a class, if it's just a single int or a sprite reference or something like that, then we don't need to do anything else. But it's possible this will have all sorts of various extra code and things in here, depending on the complexity of what we need. In which case, we might bring this out to a separate file. But for now, we can just leave it in here. That's going to be okay. Depending on how long this becomes, it may stay in here or it may go up to a separate file, but it hardly matters one way or another. We're probably going to want some sort of planet class, planet type thing. Again, it could be an integer. I think our planet classes will probably actually be represented by a enum. Planet type. We'll use that just like the sun. So it might be a little weird that one's an integer and one's a type. The thing is, for our star system, the type, like this is protected right now. In fact, we could make it private. I think protected is the default. I don't remember. We could make it whatever. This star type is not accessible from outside, which actually, normally I would go lowercase here. Same thing here. Lowercase, uppercase is reserved for things that are public, is general convention. It's a good idea to follow. Makes a lot of sense. So something like that, right? Just to remind you that, right, and people outside of this code can't access that. And so the planet type, whether or not the enum itself is public and whether or not the type is public, I don't know. It sort of feels like we probably want it because we're probably going to be displaying this type a lot or something. I don't know. And the planet graphic is probably going to rely on this. There's all kinds of different stuff. We'll figure it out going forward. But we're going to have a variety of types of planets. Now, there are going to be a few special types. All right. So, for example, it could be, and typically you put this in all caps, but I don't know. I'll do this. Asteroid and gas giant. All right. These are two special types of planets. They're not going to be colonizable. Now, we might want some other switch, you know, some Boolean, some this, some that. I don't know. There's all kinds of different ways we can organize it. Continental or terrestrial, like there's two ways, continental. There's a few different ways to refer to this. There's, you know, we might get to the point where we can do Gaussian transformation, oceanic, barren, radiated, toxic, desert, arid, tundra. There's probably something, you know, that you would typically have that I'm not thinking, but I don't know. That seems like a pretty good list, and of course we could add more. Now, we might decide to, like, arrange this in different ways. It might not be an enum going forward. We might care, if you think about something like Stellaris, what Stellaris has, it has 9 planet types, but really what it has 3 different temperatures and 3 different moisture levels, and the combination of those 2 intersections determines what the base planet type is, you know, in a couple of different ways, and it influences things like, okay, well, if you're not settling your main planet type, how habitable is it for you, and things like that. In classic Mu, species don't have planet types. They treat, they're all sort of continental or terrestrial by default, and so you don't have to worry about some weird intersection between planet types. There is toxic. There is usually a racial trait where you can be like an aquatic race, in which case, if you're an aquatic race, I believe you treat both continental and oceanic as continental as your base type. You're perfectly happy on either one because it's a positive trait. It just means that you can settle oceanic as well as continental and be perfectly happy. It also, in classic Mu, makes it so that you actually, your homeworld is oceanic over there. But, you know, something like that is fine. We're probably going to want some ability to have, like, I don't know what this is going to be, like planet traits or something like that. Like, it's, I don't think this will be an enum. I suspect this is going to be a class, but, you know, it could have, like, gold deposits. It could be an artifact world. You know, it could have all these different types of unique traits. Planet traits might become a class that can apply their own logic. Like, I don't know how we're going to work this out, but there will be the idea that when you generate a planet, there's a random chance that it'll have, you know, something else on it. Natives was something that you could get in Master of Orion. There's a bunch of others. And then, of course, we can make up our own. We can change things. We'll see, but that sort of idea. And then I think what we'll want is some sort of, like, list of planet traits, because we could have more than one. Now, most planets had 0, and I think I've seen planets with a couple. I don't know if you ever see planets with 3. So when we generate it, we'll probably have some sort of maximum. A list, I think, makes sense in this case, because generally speaking, it'll be empty. And then there won't really be any overhead, but I don't know. We could instantiate a array, you know, of size 2, and it could just contain a couple of null elements. And actually, that would have very little overhead too, possibly less, honestly, than a list, even though a list is internally an array. Anyway, we'll just leave it there. So we've got, you know, some information over here. I don't think the planet really truly needs to be aware of its position in the star system. Or does it? It might. Because I can certainly see when you're actually looking at the planet screen, right? If you're colony screen, it might tell you in the information, you know, the planet name, the planet... Oh yeah, names. Actually, star systems will need names as well. Which will be... Again, it might end up being an accessor, right? But a string, name, it's fine like that. And there's no reason we couldn't, you know, here. Get, protected, set. I mean, it doesn't matter. For now, it's like sort of overthinking it. We'll just do this. It's going to be okay at this stage in the game. I mean, you want to put some thought ahead and think a little bit for some of these data structures, but for some others, not as big of a deal. planet graphic, or we'll put up here string name, something of this nature. Boom, go like that. Right. Oh yeah. So displaying, we might want to display its position in the star system. So I guess with that, we'll put some sort of, we'll just keep it as an, you know, I don't know, I guess it could be public. It really, you know what? This is really a read only. A planet's position will never change. Now, we can destroy and create planets. Oh, now this is kind of funny because here's the thing, right? We could have a star system, right, with its list of planets over here, where it's null, null, planet, null, null, null. Right, so this star system only has a single planet, and it's in position 2 or 3, or however you want to, you know, refer to it in this particular case. Index 2, position 3. It's the third. It's in the third slot from the sun, but there happens to be no other planets in the star system. So, how do we display it? How do we tell the player? I don't know. This is going to be the planet position. I guess it could be public. Right? There's no reason we couldn't read it. The planet position, this is like the index, right? And maybe we could call, you know what? Actually, that's a good idea. Let's call this planet index. To be very clear that it is an index in an array. Same thing here. It's an index in an array. So it's possible for a single planet, like the lone planet in a star system, to have an index of anything other than 0. It could be 0, 1, 2, 3, 4, 5. These are all perfectly valid indexes for a planet that would other be totally alone. Okay. And so if we're displaying some sort of text about, you know, this is the bluff planet from the sun, then we actually don't want to use the planet index for that. We're going to have to, like, use a little function to say, hey, how many planets are between me and the sun? It's like, oh, okay, yeah, I'm in index position 3, but I'm actually the first planet from the sun to describe it to the users. And I mean, we never want to tell people we're the 0th planet from the sun, even if our index is 0. So those are two separate things, and that's fine. Okay, and this makes it more clear. I like that. I like that a lot. I think a planet will need to know if it has a colony. You know, again, maybe this is a public colony. This might be null, or it might actually have a colony on it. And a colony is where people actually live. People don't live in a planet, because in theory, we could have colonies on, you know, some other type of construct, something like that. Like maybe a colony doesn't belong to a planet. Although, for now, we can probably assume that we have something like public, planet, planet. Maybe this will change later on. I don't know. Oh, we need to namespace it. See, it's underlined here because we didn't using the Caprica namespace. Sorry, I don't want to using. I want to define. Hey, we're actually just part of the Caprica namespace. So don't worry about it. So if we do define some sort of thing, look here first, and there you go. So no more red underline. That's going to be fine. I don't think the colony itself has a name. I think we just use the planet name. That's going to be fine. Planets will have some sort of population limit. Oh yeah, planets need a size, actually. We have a planet type, and we have a planet size. Now, the planet size is probably going to be something like, actually, probably an enum. Oh, we need to move this. Actually, we need to do a couple of things here. We defined the enum, but we didn't actually keep it my type, because we can't use planet type twice. Although, if it's... Suppose we could call it planet types, and then... I don't know. I don't know how we want to naming convention this. There's probably some sort of general rule of thumb for this. I suppose if the planet types aren't part of the planet class itself, right? They could just be this, which actually I think makes a lot of sense. We could just go back to calling it planet type, and then that enables us to do this. And that's perfectly legal, which is kind of nice. And I think that's better because the rest of our code, we don't have to keep writing planet.planetType. We can just use planet type more directly. Okay, so we got this. We'll want the planet size as well. And one advantage of the enum and an integer are basically interchangeable. So we can do math based on these enums, which is going to be fine. So as long as we sort them for the size aspect based on the size that makes sense. Tiny, small, medium, large, huge. I like it. So you get your baseline of medium, you get 2 sizes smaller, 2 sizes larger. I think that's good. And so we have a public planet size over there. Good. So we can refer to those things. And the planet size will be the base for the max population, right? So we're going to have some sort of public int max population. So this is the most people you can possibly have on this planet, on this colony. And it's going to be based on the planet size. Let's say can we have consts just naked in the namespace? I think so, but really it's part of the colony. Where do we want it? No, I think putting it inside the class is good. We could just have it. I mean, we're hard coding it somewhere, and really we want to load this in from a config file. Actually, that's a good time to talk about this. Let's get a new file going on here. New item. Whatever. As long as it's a C# file to start off with. But yeah, it's not going to be a mono behavior. It's going to be part of the Caprica namespace. Oh, didn't autocomplete that one. Okay. Boom. Boom. So get rid of these. This is going to be public static class called config. This is going to be this sort of global thing that holds all our basic configuration values. And at the start, like now, it's going to probably just, you know, we're gonna hard code in some values here in one central area that we can refer to other places. But most likely, so the values are coded here for now, but the idea, the goal, will be to load in from a config file that is moddable. 2D is moddable? I don't know. Anyway, it's going to be fine. So I don't just want something like public blah. No, I don't want that. I'm going to want there to be some sort of function like public. What are the values? Are they going to be ints, floats for these configs? Maybe want different options? Oh, shoot. Actually, that is a good question that I don't know, but let's try not to overthink it. Public int get, maybe call it get int. This is going to be very similar all of a sudden to Unity player preferences, because I think it's player prefs.getInt.getFloat, those sorts of things. We'll probably do exactly the same sort of idea. So probably we want some name for the parameter or something like that. And we'll get them from some. I think for now, it's perfectly fine for us to put in some sort of switch statement. Switch on parameter. And case. Planet max population medium. Now, we might not want all caps because we're probably going to want to stringify the planet size. So something like this. Tiny, small, large, huge. And again, the idea is read this stuff in from some sort of text config file later on. That's going to make it really easy to modify. But we just return, so let's say a tiny planet has a normal maximum of 4. A small has a maximum population of 6. 8 for medium? Maybe 10. Return 12 and return 16? I don't know. We'll tweak those, right? For now, this file here, this code file, this is our config file. That's what it is. So here we'll return 0, but we'll probably want to do a debug.log error. something like no, get int no option for parameter, like that. So I guess it's not happy with that return. So I guess, that doesn't count as a return for everything. Oh, it's because, so make this a static. Is that why you're underlined? Yeah. So you're actually perfectly satisfied with this return over here, which I guess would be fine. Oh, we need a bunch of breaks too. Ha! Well, no, actually, the return ends. We don't need a break after return. That's why we're not getting a complaint about it. And it's also telling us here, this is unreachable code, which is fine. Okay, we don't need the break. Good. So now what we can do over here, we can do something like return config.getInt. And I don't like the idea of necessarily all these strings. Oh, the file needs to be renamed. Config. There we go. Like here, we need to know what the string name is. I mean, that's got to be put in somewhere. Plus planet.size.toString. There we go. So if we can end up doing something like this, so this is our population, except what we're going to want to do is modify this some more, right? So it's more like something like, okay, int p for max pop or whatever is going to be this. But then we do, so return p. But then we do something like, is our species subterranean? Whatever. Subterranean. Shut up. You're not here for my spelling. Is our species subterranean or have some other bonus to pop cap? Could be from tech 2. For example, moo to's. It had some sort of like city thing, like a mega city thing that you could research at some point. They give you like +5 population cap. Could be from a building like biospheres, biodomes. There's something like that you could build that gave you 2 extra population cap. So there's a bunch of different things. Could be from a planet's special trait. Now, there's an idea that maybe we get this max population, maybe the actual planet has some sort of like size code in there for getting this. Like maybe it doesn't make sense to run it here, especially if the planet has special traits. But at the same time, it might be useful to have it all in one area because some things might cancel each other out or not stack or something. We'll see. As we develop these various traits, we may organize it in 2 separate areas. We may have like the planet has like planet.getMax population, and then colony has, dot max population, but we'll see. So for now, something like this is going to be fine. So we'll have some sort of general thing, and that's going to be good. So it has a max population, but then we also have something like int current population, or just population is probably fine. Now, the interesting thing is, if we follow the Master of Ryan model, our population is always going to be assigned in 3 different categories. So we have int pop farmers, int pop workers. So farmers generate food, workers generate production for like building. So they could be pop builders or something. And then finally we have pop science. I'm just going to put science just because they're exactly the same. Nah. Scientists. It's fine. So really our population here is more like a return. Oh, it's a get. Return pop farmers plus pop workers plus pop scientists. It guarantees that our numbers are always going to be in sync. So you can't set the population directly, but you can set the population of these subtypes directly. And so when you're doing something like in the user interface and you're clicking and dragging, let's say you're grabbing a scientist, you're almost like you remove the scientist there and it's attached to the mouse, and then you drop it somewhere in, say, the farmers column, and then you add +1 farmers, and then you refresh the view in some way. And I think that's the sort of thing that's going to happen. I guess we're going to have some sort of building class. Now, we really don't know what that's going to look like. It's a building instance, like a built building, as opposed to a building definition, a building template. But really, it's always that problem of how we do that. Well, I think I'm just going to call the class building. And I'm going to sneeze. Excuse me. Represents a constructed building on a planet, question mark. Maybe also gets used in the list of building templates. Probably what we do is that basically all the buildings that can ever be built in the game, right, that can be unlocked by technology and everything, we create at the start, like when you start a new game or you know, you load a game, whenever you boot the game, really, we're going to populate one array, which is going to be every possible building that can exist in the game. And then when you build one, what we do is on the planet, we could conceivably just point to the building, or you know, have the building index, right? That's interesting. In our colony, we could have a list of building, which is our built buildings. We could have that, but we could have a list of integers, built building indexes. And what's interesting about this, excuse me for the sniffle here. What's interesting about this is that, do individual buildings have individual stats? Is a barracks on one planet, does it have anything that it's going to keep track of that's going to be different from the barracks on another planet? Okay, well, it's conceivable, because what if you have a building, and I think barracks may have worked this way, where a barracks or a garrison or that sort of thing are something like, okay, every 10 turns we're going to spawn a new defensive army on this planet to protect you from invasion, up to a max of, say, 4. In which case, we need to keep track of this sort of timer on this building for how many more turns before it spawns something. I mean, in theory, maybe buildings can be damaged from, like, by bombardment, individual buildings, but that's not, I don't think that's really the case. In terms of building the buildings, I think that's more of an aspect of the colony build queue. So the colony build queue will be some queue, you know, like a list, but queue type of a sort of a tuple, like a mini little structure, which is just one field in the structure is, what building are we building? And the other field in the structure is something like, okay, how many hammers towards this building have we produced? Because, like, the stats on a building will be something like, you know, a building will probably have a name, and a building will probably have something like required production, right? Required production, and it might have something like int unlocked by tech ID. So if, you know, we check the player, like, can you build this building? Like, when we're populating the list of buildable buildings, when you're looking at a colony, we look at the building, we say, oh, it has a tech requirement, like, and, you know, by default, it's probably something like -1, right? No, you this is for something that's unlocked right from the very start. But if it's 0 or greater, then we look up the list of techs that the player has unlocked and see, have you unlocked tech number 13? No? Oh, okay, then we can't actually add this building to your list of buildable buildings or something of that nature. And then it's going to need some sort of, like, I'm betting it's going to have some sort of action or func, you know, some sort of delegate for like what it does every turn. Like we can define some sort of like delegate, which is just a function template basically of like building end of turn function, which probably does something like returns void and may not even need some sort of parameter, but then it can run code, right? Like every turn you call the attached delegate, you know, blah, 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 as sort of an end of turn callback almost. And so the building might do some processing, might have some sort of bookkeeping function that it uses internally. Like we could give it a, I don't know what this is going to be like. You know, maybe we end up, maybe the buildings end up being hard-coded in the sense that we subclass everything. Maybe what we're doing is we're running Lua code, which I think would be the ideal. We don't know what this is going to look like. This is a little further than I want to get to in this particular video, but there's going to be some sort of idea with this. Anyway, built building indexes. I think that's going to be fine. So, oh right, I was talking, we can either have a list of indexes or we could have an actual link to things. And then how do we save it? Then we have a whole system for figuring out, okay, how do we save the list of buildings that are built on a planet and keep track of its progress? I suppose it's possible that, you know, we have some sort of pair where we have the built building indexes. And I think the buildings, the only thing they'll ever do is maybe have some sort of internal counter for how many turns has passed by since they were built. So we could do something like building built turn. And then we can sort of pass them back and forth. So at the end of every turn, so like we'll have some sort of like public void do end of turn. And so what this is going to do is something like for each built building, call their end of turn update and pass the value of the turn number it was built on. It was built on. Because then each building doesn't actually need anything else. It's mostly like if the building built turn, so if the current turn minus building built turn, that'll tell you how many turns ago it was built. Modulo 10, right? The percentage 10. If that comes out to 0, then that means it's been, you know, it's been 10 turns since it was built. Or I guess you might do modulo 10, and if it's equal to 9, then that means we have to spawn a military unit on the planet we belong to or something like that. Like, I don't know what it's going to be. We'll figure this out. There's like 30 million different ways we can implement this. And whether or not we do it like this, there's sort of an advantage to, like, if we can avoid having the need to actually instantiate a different copy of the building object for each planet. That makes saving really easy. That makes some of the bookkeeping really easy. And really, do buildings need to have individualized stats? I don't think so. I don't think there's any difference between a barracks built on one planet versus a barracks built on the other. They're exactly the same. They don't need to know anything about each other, except possibly, hey, how many turns has passed since I was built? Because I kind of do something every X number of turns. That's literally it. So I think if we do have this delegate, which actually, we probably want to do something like, it's going to need a link to the colony. It's going to need do you actually need, colony? I didn't think so, but all right. Int, current game turn, int, built game turn. You know, maybe there's some other things, but we start to require those things. And then here we do something like, it's sort of an event because you can accrue multiple things. But let's just say we're going to have a list because maybe we want to micromanage. I don't know. Probably just an event is fine. Sure. Event this, end of turn function. I guess, and then public void do, what did I call it on the colony? Do end of turn. And all it's going to do is actually just call this with the same values. I'm thinking there's a better way to organize this. We'll almost certainly make some pretty substantial changes. I'm just going really fast. And I'm not spending the time thinking all the way through. I actually didn't think I'd get this far in the video. It's been a very long video, so I'll put a cut in here. And so we can assign this to whatever, right? We can have some piece of code somewhere that sets this to a function, right? Like if we had public building, so in our constructor, we can set this to be equal to C turn built is going to be some function that does something with it. So this function would get called debug.log hi. So at the end of every turn, we would see for each building on each planet, we would see the word hi show up. There's going to be a better way to organize it, but this is the sort of idea. So we have this, and then we have some other file somewhere that it's like, set up all the buildings. And again, the idea will be we're going to read some sort of data file, right? Some sort of configuration file, possibly with Lua code for the building actual functions and logic. But early on, will simply be, we're going to have some sort of static class. And again, it could be in the same file. You know, some sort of static public class, just called something like setup buildings. What am I doing wrong? Oh, the word class is important. There you go. Boop, boop. Okay. And we could even have it be the constructor, right, for this static class. So it just runs. I guess we need those. It just runs as soon as the program runs. You need to be defined as static. There you go. As soon as you start the program, this function will run. And all we're going to do is we're going to have some sort of like public building array, all buildings. Or something like that. I don't like the naming convention anymore. Something about this is just bad and off. And then this is just going to be all buildings equals new. Can you actually do new? I'm trying to remember, like we can do this. And then can we do this where it's a new building with some sort of stats? Yeah. Boom, 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 boom. And then building would have a constructor where we'd actually pass things to it, like a name and a function. So this sort of idea, so this is going to take in something like string name, well, actually lowercase that, string, yeah, I don't know, we'll have it be the same, it's good, okay. Boom, boom, oh, this is an int, unlocked by tech ID, and then finally a building end of turn delegate. We'll just call it func. And so we just cut this out, set it to func. 1 second here. So this is going to be barracks. It's going to need 100 production or whatever. It's not unlocked by any tech. You get it right from the beginning, although probably that won't be the case. And it's going to want some sort of function. So we'll pass it a function here. There's a million different ways we could pass it this function. We're just going to do this for now for debugging purposes. That's going to be okay. Here. Barracks, turn, processing. Ooh, like that. And so over here, what are you whining about? Oh, this delegate needs to be public so we can share information about it. And you go this dot name equals name. this dot required production equals required production. This dot unlocked by tech ID equals unlocked by tech ID. And just to be consistent, this dot end return function, boom, like that. So, something of that nature. And there you go. So now we have this building setup code. And again, this function will instead read a config file with building parameters plus maybe Lua code for end of turn logic. And a building's probably gonna need more than that, because I mean this is set up fine for a building that all it does is process something every tick. But what about a building that gives you bonus production? What about a building that gives you bonus science or has some sort of impact on the colony? How do we do it? There probably needs to be another function that runs when the building gets created or when the building gets destroyed, so that it can tweak numbers in the colony stuff. Or maybe it's a callback that modifies something. So the colony says like, okay, my production per turn is blah. Well, what is blah? Well, for each building that I have to say, hey, by the way, I have this kind of population, and whatever. Now tell me if this building gives me any production. For most of the buildings, the answer would be 0, but some buildings might give you a flat 10 production per turn. Other buildings might give you an extra +2 production per population. And so each one of those would return some sort of value. So there needs to be a lot more going on here to cover all of our various use cases, but it's going to look something kind of like this. There might be many functions that are callbacks every time a turn gets processed, or there might just be a pair of callbacks that is when the building gets built or if the building gets destroyed. So what we're doing is, when the building gets built, so the colony might have some sort of values over here, like int flat production and int production per worker. Okay, 2 values like this. And so flat production will probably be 0, right? Normally 0, unless you get automated factories. Oh yeah, our planet needs a base richness level. Type size, something like planet richness. Public enum, so poor, abundant, rich. Oh yeah, there'd be very rich and very poor, I think. Something like that, where the base production of a colony per worker is something like planet richness +1, right? So very poor is the 0th enum, so it would have a production per worker of 1. I think, in fact, it's probably something like planet richness divided by 2 +1. I think that's probably much more typical. And you can round, so this would be like, so a poor planet gets a ½ a point of production per worker. An abundant one gets 1 point of production per worker. Well, +1, sorry, +1. So it would go, the production for these would be 1, 1.5, 2, 2.5, and 3 production per worker finally. I think moves something like that. And again, we don't have to copy that. We'll come up with our own thing, but that's a general idea of this. So we set this, so something like public, it could be an int, because we might round the actual production number to an int. Total production per turn becomes something like return flat production plus production. Are you whining? Oh, because I keep forgetting to put in my parentheses. I think I keep taking it for granted it's going to auto-complete it. Production per worker times pop workers, like that. And then the idea being, when we build a building, it might tweak this, right? Let's say you build a factory that increases your production by worker by an extra 2 production per worker. So on building the building, you add +2 to this. And if the building gets destroyed for some reason, we have to make sure to take away that +2, so you -1 it. And that's probably the way we'll go. as opposed to some sort of like also loop through all buildings with some, you know, and so for that we need some sort of function call like that exists on each building that is, okay, modify my workers per whatever. And then all of a sudden our building class gets very complicated because we have a function call for, oh, we need to check our production. We have another one for farming, another one for science, and maybe more for other things. Maybe it's just those three, in which case it's not so bad. It's actually probably not so bad. So our buildings really could just have a trait that is something like int, you know, bonus flat production, etc., etc., etc. We don't know how we're going to organize that, though, and we'll put a cut in here. I think this is good work for our overall structure here. Again, when you look at like lines of code written, there's not a lot of lines of code written here, but I think it's very good. Thanks for watching, folks. We will see you next time. This episode is brought to you thanks to the awesome people who support me at patreon.com/Quill18, including these Mic Check supporters. We've got Armin Nobari, we've got Rarskal, we've got Ewald Schult, we've got Jason Yanity, Jeff Fellows, John Pavlik, Jordan Smilovich. We've got Tiburon, we've got Julien Auger-Lafont, we've got Marius Fieldvold, Martin Bauer, Michael McClintock, Mighty Mix, Neil Blakey, Milner, Pavel Zdanov, Speedy Savant, Steven Sager, Thomas Oberson, and everyone who watched, shared, favorited, and subscribed to these videos. Thank you so very much.